Welcome to the video for Chapter 4, Lesson 2. This is just a closer look at properties about equilateral and isosceles triangles. In addition to equilateral and isosceles triangles, we did briefly mention equiangular. Equiangular is when a triangle has all three angles congruent. And so when we look at an equiangular triangle and the fact that there are 180 degrees inside of the triangle, then this theorem says that because we have 180 degrees split evenly between three angles, I can divide, and each of them will be a measure of 60 degrees. So if a triangle is considered equiangular, each angle must be 60 degrees simply because of the fact that there are 180 degrees in a triangle, and if we split them evenly, that makes each of them 60. This is the proof for the theorem above, that every angle inside of a equiangular triangle is going to be 60 degrees. If you notice, this is given that it's an equiangular triangle because it is equiangular, so the definition of equiangular, each of these angles is equal to each other. All three angles in a triangle add up to be 180 degrees. That's the angle sum theorem. And then the only difference between line 3 and 4 is that the A, B, and C were all switched out for A's. They could have been all switched out for B's or all switched out for C's. That doesn't matter. They're all the same because of substitution, because they're all the same values, because they're equiangular. So then from here, line 4 to line 5, it's just combining like terms. If I have 1, 2, 3 measures of angle A, then I can just write that as 3 measures of angle A. And then we divide by 3, and you find that the measure of angle A is 60. Well, because the measure of angle A is 60, that means the measure of angle B is also 60, and the measure of angle C is also 60. This is all a very formal way to say that we're just going to take the 180 degrees and divide by 3 to get 60 degrees. This proof is here to reference the theorem from a previous lesson about the acute angles in a right triangle being complementary. This is just to take a look at another example of proof writing, since we will be doing that in a later lesson. This diagram shows the important takeaways about equilateral triangles that we're getting at. And the deal with equilateral triangles is that when we have a triangle with all three sides congruent, it also ends up being equiangular based on the 180 degrees being split evenly. There is a relationship between a triangle's angles and its sides. And so if I have three equal angles, I'm going to have three equal sides, and vice versa. If I have three equal sides, then I can say that the angles are congruent. So equilateral triangles, everything is equal. All sides are the same and all angles are the same. The one takeaway I want to make sure that we're getting here is that the angle space, the inside angle space, is where the 180 is. The side lengths can be whatever, 5 inches, 5 inches, 5 inches, 10 yards, 10 yards, 10 yards, 50 miles, 50 miles, 50 miles. There is no 180 on the side length. There's no stopping how long, how big, or how small the sides of the triangle are. It's the angles that all have to add up to 180. And this is the diagram that takes a closer look at isosceles triangles. So isosceles triangles have two congruent sides. Those congruent sides are called legs. In between those congruent sides, at the top, normally is called the vertex angle. This angle can be whatever it wants to be. But because there is a relationship between angles and their sides opposite, because we have two congruent sides, we're going to have two congruent base angles. So this is the base side. It's not uncommon to call the bottom part of a triangle its base. Specifically in an isosceles triangle, it's the side that's not the same measure. So I've got two legs and a base. So since it's on the base is the bottom, these are called base angles. These base angles are congruent. These side lengths are congruent. And so what ends up happening is that if we have an example, let's say this is like 70 degrees up there. And so if that's 70 degrees up there, I can subtract that from 180 and get 110. That I now can divide by 2, because if 70 is up here and these base angles are equal, they're going to share what's left equally. We are allowed to split it in two to make that 55 degrees. So each of these angles is 55 degrees. And it can be anything that adds up to 180. This is just one example. This could be 40 and 70 and 70. So many options happening here. But the point is that the vertex angle is the one that's between the two congruent sides, so it's between it. That's the one that's different. The base angles kind of opposite those legs, those congruent legs, those are going to be congruent angles. And so we are able to set things equal to each other. We're able to set things equal or add and subtract from 180 as necessary. Definitely lots of relationships in isosceles triangles.